Hi students, I hope you are doing well. So today we are back with a new video on the topic circles. Okay, theorem, second theorem as I told you, both theorems are very important. So today we are going to discuss the second theorem of the chapter. Okay, what is this theorem? Basically, the last theorem we already discussed, like a tangent drawn. Correct. It means just brief it. OQ is perpendicular to PQ. That is only we discussed, right? A tangent drawn through a point of contact. So if you draw a tangent through the point of contact, the radius of the circle is perpendicular to that tangent. Correct? It means OQ is perpendicular to PQ because PQ is the tangent for the circle. And what is the point of contact? Q. So OQ is the radius of the circle. OQ is perpendicular to PQ. This was the, this was the theorem we discussed in the last class. So today we are going to use the theorem to prove this theorem. So that I will discuss. Okay. So the theorem statement is the lengths of the tangents drawn from an external point to a circle are equal. It means the meaning of this is if you draw or if you take any point outside the circle. For example, like I'll just explain here briefly. This is a circle. We are taking any point outside. Remember, any point outside, not inside the circle. Imagine that outside you are taking one point P, and this is the center O for this circle. And if you draw one tangent to this circle, and again if you draw one more tangent to the circle from this point, it means how many tangents you can draw from this point? Remember, it is only two tangents you can draw. From the point outside the circle, anyway, you can take anywhere. For example, I am considering a point outside the circle P. Again, you remember not inside, outside. Outside, I am taking a point P and I am drawing two tangents. Correct. So, these two tangents, only we can draw two tangents. And what we are going to prove, for example, this we take it as R, this we take it as Q, and PQ, the length of PQ and length of PR should be equal. That is the theorem. It means if you consider any point outside the circle, from that point if you draw two tangents on the circle at two different points, so the length of those two tangents should be equal. Okay. Example, in this case what we have taken from the circle which has a center O, okay, and we have taken a point P outside the circle, and from the point P we drawn two tangents. Okay, tangents means there should be a point of contact. Here point of contact is Q and here point of contact is R. The length of P and Q means PQ, and the length of PR tangent length. If PQ is one tangent, PR is another tangent. So we have to prove that PQ should be equal to PR. That is only we have to prove. So the length of PQ and the length of PR should be equal. That is only the proof we have to do. Correct. So I'll just repeat the statement. The lengths of the tangents drawn from an external point to a circle are equal. So that is the statement which we have to consider. And given. First you have to write given. See, whatever the working, whatever the given to proof, whatever I written on the board. Okay, this is in the textbook. It is in a easy, not exactly easier way. They just directly written. It means which you cannot understand easily. So I make it very simple. Okay, I made it very simple so that this notes will help you to, understand the theorem easily. So maybe little compared to the textbook, whatever the written material is more, but still you can easily understand this book. It is an easier way. Okay, understood. Easier in the textbook they used similarities. I am not using that here. I'm just proving in the other way. This is a method 2. Okay, to make you understand easily. So carefully listen. Given let the circle be with center O. Imagine we have a circle. It has a center O, and P is a point outside the circle. We are assuming. And PQ and PR are the two tangents or to a circle intersecting Q and R respectively. So this PQ is touching or intersecting. PQ is touching, okay, or P and the Q is the intersecting point here and R is the intersecting point here. So what are the tangents? We have PQ and PR. So PQ and PR are the like two tangents which are intersecting at the 2 points Q and R respectively. So that is the construction part, so given part. So to prove, correct, what we are proving, we have to prove that length of PQ and length of PR are equal. So we have to prove PQ is equal to PR. Next, construction. What we are doing, constructing part, we are joining OQ, just join this, or you can put in dotted, actually, dotted marks also, dotted lines you can put. So OQ we joined and OR we joined, correct? So OQ and OR and also OP is joined. So all these three they are joining. So this comes under construction. This they only given. Remember, given means they already given this in the theorem or whatever it is. And construction means we are doing it. Okay. So that's the reason we are putting a dotted line here for this. So now, after this, what we have to prove? We have to prove PQ is equal to PR. Correct? And construction, as we did, OQ, OR and OP, we joined. So what is proof? Proof, first thing in the proof, as PQ is a tangent, correct? As we assume PQ is a tangent, in the given it is clearly written, PQ is a tangent. If PQ is a tangent, OQ, from the theorem 10.1, means last theorem we discussed, if PQ is a tangent, this OQ should be perpendicular to PQ. Okay? You don't need to write anything, just write from theorem 10.1. From the last theorem, okay, this OQ, okay, last theorem you might have like understood how I proved, okay, just like this OQ and this you take it as PQ, okay. So obviously this you take it as some MN, any line MN or line whatever it is. So OQ is perpendicular to MN, correct. This was the proof we did for the last theorem. So similarly here, we can consider this PQ as a tangent. I didn't prolong it, you can prolong it if you want. If you have any doubt, you can prolong. Okay, this will become one line, right? So obviously OQ is perpendicular to PQ. If this is perpendicular, what we can say, the angle OQP is 90 degrees. Isn't it? Always a perpendicular makes 90 degrees. So angle OQP will give you 90 degrees. So if angle OQP is 90 degrees, can I consider this triangle OQP as right angle? Correct. This Q makes 90 degrees in the sense, if one angle in any triangle makes 90 degrees, then the triangle is considered as a right angle triangle. This is a very basic thing you might be knowing. So triangle OQP is a right triangle, or you can also write it as right angled triangle. Both of them. So we can conclude that triangle OQP is a right triangle. Similarly, same way, PQ is a tangent and also PR is a tangent. In the same way, PR is also a tangent. If PR is a tangent, this OR is perpendicular to PR from the theorem 10.1. How OQ is perpendicular to PQ, similarly, OR is perpendicular to PR. Correct? Because same from the theorem 10.1, whenever you draw a tangent on a circle, always the radius of the circle is perpendicular to the tangent. That was the theorem, correct? So OR is the radius. Again, here also OQ is the radius, correct? So because radius is same everywhere, correct? This is also radius and this is also radius, so radius is same. So obviously radius OQ is perpendicular to PQ and radius OR is perpendicular to PR. So from theorem 10.1, OR is perpendicular to PR. So we can conclude that angle ORP is 90 degrees. If ORP is 90 degrees, so this angle, this triangle ORP is a right triangle, means right angle triangle. So we proved that, or we got it like two triangles as both are this triangle OQP and triangle ORP we got as right triangle, means right angle triangle. And always you might be knowing in a right angle triangle, because we don't have space here, so I might remove some portion here. Okay, so adjust with that. So triangle ORP is a right triangle we know, correct? Fine. Let me consider, all of you know Pythagoras theorem, right? So let us consider triangle ORP. If we consider from triangle ORP, or the first one you take it as OQP. First, let me go with the first triangle. Okay, which is the hypotenuse, and all of you know that hypotenuse is the longest side. So if you look at this, this is actually, I'll draw the separate triangle and show you. This comes like this, almost like this. Yeah, okay, you can draw like this. So can I take this, okay, what you can say, like PQ as hypotenuse, sorry, OP as hypotenuse, because OP is the longest side. Correct? OP is the longest side compared to PQ and what is it? OQ. So I will write, okay, OP square is equal to OQ square plus PQ square, because from the Pythagoras theorem, we know that hypotenuse square is equal to the sum of the other two sides. Sum of the squares of the other two sides. So if OP is the hypotenuse, so I am squaring OP. So OP square should be equal to the, what are the other two sides? PQ and OQ. So sum of the squares of the other two sides. So what is the square of this? PQ square, and what is the square of this? OQ square. I'll repeat once again. What is Pythagoras theorem states? The square of the hypotenuse in the triangle OPQ, what is the hypotenuse? OP. So OP square should be equal to sum of the squares of the other two sides. What are the other two sides? OQ square plus QP square. So sum of the other two. Correct? So OP square should be equal to the square of this side plus the square of this side. So PQ square plus OQ square. Correct? So that you keep it, and OQ, this we will write it. I hope you understood from this. Any doubt, let me know. Like you can you can reconsider, or you can just look at once again, you will understand. It's not that much difficult. Okay, so OP square can be written as OQ square plus PQ square. So now, can I write, okay, let it be like this. And let me consider one more triangle. What is that? From triangle, another triangle is what here? From triangle ORP. Okay, from triangle ORP, can I write, again see, OP is the hypotenuse, isn't it? OP is the hypotenuse. Or one more thing we can easily do here. Can I write this as, okay, let me go with this. From triangle ORP, okay, OP square is equal to, which is the longest side again? Here also OP is the common side, so OP square is equal to OR square plus PR. Correct? OR square plus PR square. Doesn't it? OP square is equal to OR square plus QR square. So both the sides you see, OP is the common side, isn't it? OP square in the LHS here, and again OP square is there in the RHS here. Correct? I hope you understood. Here also we have OP square in the LHS. Here also we have OP square in the LHS. Can we equate both? Because LHS is same, your RHS should be the same. So OP square plus PQ square is equal to OR square plus PR square. Okay, so now here you have to understand OQ and OR should be the same. Can you tell me why? Because always radius of the circle is same, correct? Radius of the circle is same. Radius of the circle, why? Because you might be knowing it, right? This radius, this is called as radius. If you take this as R, then this should be R, correct? Same radius, this we already discussed in the last video. So this distance and this distance should be same. Even if you draw this, this is also R. So this radius is same everything. So here Q is also radius and OR is also radius. So OQ should be equal to OR. Can I substitute in the place of OQ plus PQ square is equal to, in the place of OR, can I write, I'll just write this in the, I'll just erase and write so that you are not able to see that properly. I'll just erase here. Yeah, what is given? OP square and I hope you understood that. We got OP square is equal to OQ square plus PQ square, and OP square is equal to OR square plus PR square. Both the sides LHS is equal. So you can write this as equation 1. Okay, this you can take it as equation 1, and this you take it as equation 2. Okay, so I will write from 1 and 2. Okay, from 1 and 2. Can I write, okay, if LHSS is equal, can we equate RHS? So we can equate OQ square plus PQ square is equal to OR square plus PR square. So here if you observe, can I write OQ is equal to OR because, okay, OQ is OR equal because OQ is equal to OR because radii of circle is equal. Okay, our radius of circle is equal. Anything else? Always radius of circle is equal. So OQ and OR are same. You can replace OQ with OR 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 with OQ. Anything is fine. So for OQ square, PQ square is equal to OR can be replaced with OQ because radius of the circle is always equal. So I will cancel OQ square, OQ square. So what you get? PQ square is equal to PR square. If PQ square is equal to PR square, can I write PQ is equal to PR? Correct? Or you can root on both the sides. Okay, very simple example. If 2 square is equal to 2 square or anything, for example, here how can I explain to you? PQ, PR, it means like if squares are equal. For example, if 2 square is equal to 2 square, then 2 is equal to 2 or 1. Very simple example. If 4 is equal to 4, definitely 2 should be equal to 2. It means if 2 square is equal to 2 square, then 2 should be equal to 2. Correct. If exponents are same, bases should be the same. Correct. So the same way, I have just explained with the numbers. So PQ square and PR square are equal, we are telling. Exponents are already equal, even bases should be equal. So if PQ square is equal to PR square, then PQ is equal to PR. One more way you can understand, take square root on both the sides. See, 2 square is equal to 2 square. Take square root, it becomes root of 2 square, and both the sides are taking square root. Square root will get cancelled. 2 is equal to 2. Like this also you can understand. Anything is okay. Take square root on both the sides. So square root will get cancelled. Here square will root get cancelled. Square and root will get cancelled. The other thing will become equal. So here PQ, if PQ and PQ square and PR square is equal, then obviously PQ is equal to PR. We can write hence proved. Okay, this is hence proved. I hope hence proved everybody knows how to write it. Okay, hence proved. That's one. That is your theorem. Okay, so this is very easiest theorem, but maybe little more writing part is there. But theorem is very easy. You can easily prove it. Okay? And as I told you, this is a theorem for 3 marks for your final exam. Either this theorem or the theorem which we discussed in the last class. Anyone you will get for the final exam. Okay, anyway, I'll just repeat once again. What is the theorem we have to prove? The lengths of the tangent drawn from an external point to a circle are equal. It means any tangent, for example, if I take P as an external point, if you draw PQ as one tangent and PR as one tangent, so the length of PQ and length of PR should be equal. That is the thing. Correct? That is the thing we have to prove. So what is given? Given that already they only given PQ. And this one are only for your understanding. Don't write it. Not exactly required to write. Okay, fine. The length of PQ and length of PR should be equal. What they given, they already told that PQ and PR are the tangents of the circle. PQ and PR are the tangents of the circle. So this is one tangent and this is another tangent. What we have to prove? This length, if this is 2 centimeter, this should be 2 centimeter. If this is 3 centimeter, this should be 3. That is only we have to prove. So we have to prove that the lengths are equal. Correct. So construction part, they are already given. So to prove is what we have to prove that the lengths are equal. And what is construction part? Construction part is just you join these two, OR and OQ. You can use dotted lines, use pencil and join. This is construction we are doing. Given what is already given in the, they are only telling that they are tangents, but OQ and OR and OP we are joining. Means we are constructing. This comes under construction. Whichever you do on your way, and from your point of view, something you are doing any like for to get proof, we have to do some construction work. Means you have to join or you have to draw something more. That and all comes under construction. Means construction which we do, given what they already given. So see the difference. Okay. So construction, what we did, we joined OQ and what we joined OR and we joined OP. So now proof. What is proof? We already know that PQ is a tangent. If PQ is a tangent, from the theorem 10.1, which we discussed in the last video, from that theorem, always if any tangent drawn to a circle, for example, here PQ is a tangent drawn on the circle, what is the point of contact? Q is the point of contact, correct? So always the radius of the circle is perpendicular to the tangent through the point of contact. It means OQ is perpendicular to PQ. That is the theorem 10.1. From theorem 10.1, we can say that the radius of the circle OQ is perpendicular to PQ. And write the reason from theorem 10.1. If you don't write it, they will deduct the marks. You have to tell the reason or you have to explain the reason. At least you have to specify for what reason you are you're writing that OQ is perpendicular to PQ. That reason is from theorem 10.1. It means we can easily understand that is from the theorem 1. And so we can, if that OQ is perpendicular to PQ, this angle should be 90 degrees, right? Always the perpendicular makes 90 degrees. So OQP means this angle Q is 90 degrees. And if any one angle of a triangle, in any triangle, if any one angle of a triangle is 90 degrees, the triangle is considered as the right angle triangle or right triangle. So we can write triangle OQP is a right angle triangle or right triangle. Similarly, PR is another tangent here, and so this is from the same theorem. Okay, OR is the radius, correct? OQ is also radius, and OR is also radius, correct? So here this OR is again perpendicular to PR. Same thing from theorem 10.1. Okay, because this is also a tangent to the circle. So OR is perpendicular to PR from theorem 10.1. And we can also say that if it is a perpendicular, definitely this angle R should be 90 degrees. That you guys will be knowing. So angle ORP is 90 degrees. So we can say that triangle ORP is a right angle triangle or right triangle. So from triangle OQP, let me take the first triangle OQP, OP square, which is the longest side in this triangle OQP, which is OP, right? So OP square means hypotenuse. What is the Pythagoras theorem, guys? You might be knowing this statement of Pythagoras theorem. Pythagoras theorem statement is in any right angle triangle, the hypotenuse, the square of hypotenuse is equal to the sum of the squares of the other two sides. I'll repeat the statement. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. It means in the triangle, right triangle OQP, OP is the hypotenuse. Which is the, how can you say OP is the hypotenuse? Remember, always hypotenuse is the longest side in the right angle triangle. Correct? So hypotenuse is OP. So OP square, what are the other two sides? PQ square and OQ square. So OP square should be equal to the sum of PQ square and OQ square. So I written OP square is equal to OQ square plus PQ square. You can write from Pythagoras theorem. From Pythagoras okay, this, how can you write? Because of Pythagoras, this reason also is specified. So from triangle OQP, you can write OP square is equal to OQ square plus PQ square, and from triangle ORP, again that is also a right angle triangle we proved. So which is the highest side? OP square, because OP is the common side for both the triangles. So OP square is equal to PR square plus OR square. Correct. So from 1 and 2 you see, from equation 1 and 2, LHS is same. left hand side of the both the equations is same. So if LHS is same, can we equate RHS? So we equated RHS. So OQ square plus PQ square is equal to OR square plus PR square. Correct. So, and as we know, OQ and OR both are the radius of the circle, the center. So can I write OQ is equal to OR because radius of the circle is always equal. So in the place of OQ, I can, or in the place of OR, I can substitute OQ because both are equal. In the place of OR, I am substituting OQ. So OQ square will get cancelled. You will be left with PQ square is equal to PR square. So as I said, 2 square is equal to 2 square. It means 2 should be equal to 2. Correct? Because see, if bases are same, sorry, exponents are same, bases should be equal. This is an exponent formula. It might be, you might have studied. So in this case, if PQ square and PR square is equal, then PQ should be equal to PR. Or one more way you can even also prove this. Just take square root on both the sides. See, 2 square I take. I just taken the square root. Whenever you take square root on both the sides, square and root here also will get cancelled, square and root here also will get cancelled. So 2 is equal to 2. Similarly, if you take square root for this, it will become root PQ square is equal to root PR square. Square is cancelled. You will get PQ is equal to PR. You can even write like this. Okay, so PQ square is equal to PR square. So which will give you, if you take square and root will get cancelled. You will be left with PQ is equal to PR. What is PQ? Length of the tangent. What is PR? Length of the another tangent you drawn. So we proved that the lengths of the tangents PQ and PR are equal. That is only the proof we have to do. I hope you understood. Okay, this theorem also important. As I said, both the theorems are very important on your examination point of view. I hope you understood. Okay, thank you very much. Please kindly, please support us by sharing the video and subscribing to us. Thank you very much. Have a great day.